a few tutorials on. In fact, let's take it from the top. Let's start with the classification, and then we will get to creating accuracy assessments and all of that. But I think we should start from the beginning. So you can download a composite data. You can download the composite data from using the Google Earth engine. I have some scripts. I will include it in the comment section, or I'll add it to the description so that you can use this code. I have these scripts for when you want to composite data, and then also to find some of the regions. So you can use these scripts. You just have to. This is for Kita Municipal. So you may have to just change the districts that you want, and you'll be able to get a composite data. So you can see this is Kita, right? Let me see. Yeah, Kita Municipal. So this is a composite data, but you can also download the individual bands from USGS, United States Geological. Let me see. I should have USGS. So you can just go ahead and then enter the site, Earth Explorer USGS, and it will open this space for you. I'm already signed in. You can see my name. But if you don't have access to this page, you have to, if you are not registered, sorry, you just have to register, and then you can now look for the area that's you can download the data sets for the area that you want to work with. So let's say we want to work Winneba. So Winneba. So this is the Winneba, the longitude and the latitude. So it's giving me just 1 point for Winneba. So I can say use map so that I can get this whole area. So if you think this is what you want, then fine, you go ahead. Better still, you can also move these points around so that it will define your area, your steady area for you. So whichever you want to do it, you come down, you specify your cloud cover, maybe 10%, 20, it's fine. Then the dates, whether you are downloading, you want the data from 2012 or whichever year, you put it there. To which year, today or any other day. So you specify the dates you want to deal with, and then um, you go to data sets, you look for Landsat data, and there are two categories. There's level 1 and level 2. I think one has been worked on, the other has not. But if you are using it for land classification, you download level 2. So you can see Landsat 8 or 9 here, and then you select the Landsat data that you want. So we've selected Landsat 8, and then we'll go to results. So it's going to scan the area and then give us the results for the prompts that we queued in. So you can see if I click on the footprint here, it's telling me I will get the data set for this area, of which my coordinates falls in. So any of these, you can just click on this button here and then you download the data. So um, so when you come here, depending on what you want, you can specify, you can just download the bands. So for example, you can see this is band 1, band 2, band 3. So if you are working on something that you will need only band 4 and band 5, you can just click on this button beside it. You can see 83.66 MIB. All the bands are here. Better still, if you want to download everything, all the data, you just click on this button at the top. You can see 854. So you just click on it, it will download the data for you. So you see that it's now downloading over here, but I'll cancel it because I have data already. So this is how to get the data. So we are using this extraction will give us the individual bands. So for the purpose of this tutorial, let's create a folder on the desktop. So we will name this folder tutorials. Okay, let's make it tutorials, and then let's put a few items in. I have the data that I downloaded. I have some of them, so let's just put them in here. Okay, so let's do it this way. So we'll extract the data into tutorials here. Let's do same for this. In fact, let's verify first. Okay. So because the files are zipped, I am unzipping all of them. So that's how come we have this. Let's also get this data. Let's add shape files to this folder, and then I also have some composite files, just like what we did in the search engine. We can still do same when we extract the data from the Google Earth engine. We can get a composite data. So um, so we can use this harmonized data. This is also a composite data that I downloaded, so we can also place it here. So we are going to work with this folder. Later we'll add some other files to it. So we'll go ahead and open ArcMap, and let's go to new. So new map. Let's call this tutorials, and then we will save it in our projects folder. So let's keep it there by default. So let's add this connection. Let's add a folder. We should add a folder from our desktop, right? So we'll look for tutorials, and then we will add this folder. You will not see it here unless you go to your catalog. So when you come here, you find your catalog here, you open folders, and you see tutorials over there. So all the data should be here. So now um, okay, so we will import a few. Let's use Landsat 8. We will import just a few bands. Let's import from band 8, band 2, 3, 4, 5, 6, 7. So you can just press shift and then select up to the number of bands that you want. So we've selected up to band band 8, band 11. This is Landsat 8, so band 11. However, you see this file over here, because we downloaded the bulk. You see this file, the one with the MTL. It also contains a composite data, the one that looks like a satellite beside it. It also contains a composite data, so we can just use this data. But then, like I said, let's take it from the top. So I'm just going to load this. You just right click and then you say add to map, and then when you come back here, you should see those bands here. I believe it's loading, so use this choice, yes, and then yes again. We should have about 11 bands, so you should do this for 11 times. So you see, we have all the bands loaded here. We have all the bands here. Now, so you can see from band 11 to band 2. The next thing we should deal with is let's classify this image. Since we didn't use the composite data, let's classify it. So we can look for no no let's create a we will first of all create a composite of these bands. So let's go to um, okay, we can just do this. We can go to geoprocessing here, and then we will look for composites. So we will input the raster. That is the bands that we have here. So we'll start from band 2, we'll do band 3, band 4, then we'll do band 5, band 6, band 7, band 8, band 9, 10. In fact, we will not need all of these. Depending on the work you are doing, you can just composite just 2 of them. Band 4, band 5 should be fine. But for the purpose of this study, let's just keep it this way. I'll keep the outputs in my default folder. So let's run this. We now have our composite data, this one. So we can just we can remove all of these ones. We can remove all of them. I just want to keep them for now. So let's just keep it. And then we will use this. So our red, it this way. This is our forest color. So you can see we have water around this area. We can also see that the red area should be vegetation. I think so. Let's see. Let's see from let's try and add a base map here. So we use the hybrid. So I think the red area should represent vegetation. So when we take this off, we should, yeah, so you can see there is vegetation. All right, so I think we are on the right path. So now that we have a composite data, the next thing we have to do is to um, classify this data. Now in classifying this data, um, we will go to imagery. Then you will see, so it's because this is not showing because we've not selected this. We have to select the composite data. That's the image we want to classify. Then you come to classify tools. Then first of all, you want to create training samples for you want to train your machine to recognize certain features, so all the pixels, so that when you recognize a particular pixel, it knows that okay, uh, this is this and this is that. So you click on the training, and then when you come, we have predefined um, schema over here where you can just manipulate, you can edit, and then you are fine. But let's create a new one because we don't want the video to be very lengthy. So let's create a new one, then we just have about 4 um, classes. So you come to new, and then you can edit it to COT is fine. Let's save it this way. You right click on it again, then you go to edit. Sorry, you right click on it and then you go to add new class. So then the first class will be water. We should select blue for water and the value will be 1. Okay, so we click on this again. We'll go to add new class. The next one should be forest and the value should be, let's make it vegetation. Vegetation. So the value should be 2 and we will select color green and so that is it. And then we will select this one too. We'll add another class which should be what else do we have here? Okay, so we can do it Bearland. Let's do Bearland. The value should be 3 and we can select maybe brown. Yeah, brown is fine. And then our last one should be built up. Okay, should have built up and that should be 4. We'll select red. So you have 4 different classes. Now we can just start classifying or creating the samples. Sorry, any of these shapes, you can use any of these shapes. So just so that oh, so we are training for water. So you click on this, you select your water, you just draw on it, you draw these shapes on the water environment. You can also use these shapes. So for example, you can just do this and then you can do this also, and then you can do this also, and you can select all of these and these ones. So you can map, you can select as many as you want. So all the areas that you think fits water, you select it, you map those areas, and you do you look for, okay, so there's another one, we should have another water area here. You can do as many as you want, but because of the tutorials, I will not do many because of time. I think we have another one here that is also water. Okay, so it's I think it's fine. Okay, we should have another one here. So as you can see, this is Lake Posumtree. So I think it's fine. It's fine. So when you are done, you come to the side and then you select all the water samples. Then you merge it into one. So you press on collapse so that it becomes one. and then you can see the number of samples that you took. That's 23. You do same for vegetation. You click on vegetation, and because we are using false color, I believe all these red areas should be vegetation. Let's see. So we should have vegetation. We should have vegetation. All of these should be vegetation. And we should have vegetation. Just make sure you've selected enough samples all around the image. So I think this is also fine. We have so when you are done, you come back here, you merge all of these together. The vegetation, you merge it together like this, and we have 18 samples. You should try and get more. Then we'll come to built up. Then we'll go back to Bearland. So let's see built up. I believe these areas should be built up. This area, Kumasi. So those white ones that you see that all of them, they are all built up areas. Asokore Mampong and all of these here. So you can just do this, draw these samples on it, and you are good to go. You should take your time and sample it well. Not like this, but you should zoom in and then sample the areas correctly. So this is Konongo. It's also settlements. And I mean, can do a lot. Sometimes you can also see the areas. Okay, so this is Techiman. So you can see it as a particular feature, but it will be showing that feature because of the spectral, because of reflection. Probably that thing is a shadow, and the reflection is showing it as a different thing. So as for this is Techiman, it's a built up area. I think we've had enough. Let's merge it. So we merge everything over here, and we have 40 samples. Let's go to Bearland. So you see, click on Bearland here. Let's see Bearland. So we are looking for bare land. Okay. All these ones, they look like vegetation. This is settlement. This is also vegetation. Okay, so let's not waste our time. Let's do it this way. Let's just take the bare land out. When you are doing yours, you have to show all of this. So we have three different samples here. So let's save the sample. Let's save it to the tutorials folder. So save it as training suits. So we'll save it here. And then we will now go and classify. You go to imagery, you click on classification tools, and now you come to classify. So you realize we should stick to the vector machine, and then you go and locate your training sample, the one you just saved. And I think we saved it in folder in tutorials, and the training is here. You can see TUT, training TUT. So you pick it and put it here. The samples, those are the points that will be created on the image. So you can decide to reduce it if you want to, but 500 is fine. We'll keep everything as it is, and then we'll classify data. So this is our original data. So look at so meaning this is Kumasi built up. This is also a built up area, and there's a water body, then Lake Busumtree. It's not perfect, but it's fine for the purpose of this this study. So so we can take this out and then keep it this way. Now we have our classified data here. What's the next thing we are supposed to do? We are now supposed to create accuracy points. So we are now going to do what we call accuracy assessments to verify whether the classification we did was perfect. It was accurate. So same way you go to geoprocessing, just look for accuracy assessments, or you can start with create accuracy assessment point. You can see it over here. So create accuracy assessment point, you click on it. Then you look for your input raster, and that should be this our classified data. So we are going to use ground truth. Now when we are done with this, we are going to send this data into Google Earth, and then we'll verify the veracity of the points. So depending on the number of points that you input here, those are the number of data or points that you have to work on. You have to switch between Google Earth and then ArcMap. So let's choose, I think we should choose 100. But if you are doing a research work, if you are doing any other work, you should choose a higher number, because the more points you have, the more accurate your number is. And then we'll keep this one also at stratified random, so that the the larger areas, the larger areas will have more points than the smaller areas. You see, this is water, this is water, this is water, and you can see vegetation is, in fact, built up area is the largest here. Um, you cannot give 10 points to this area and give 10 points to water. So let's use this strategy, and then we will run it. Failed. Could not place enough points per class. Okay, so I had to change the points from 100 to 500 and it worked. So now our accuracy points, we have created our accuracy assessment point. So as you can see, the points are now displayed over here. So what is the next thing? Let's come back to it again. So all I have done now is to just create a selection. So this is a selection of I created this layer from, I think it should be a table view. You can use any other shape file. So all I have done now is to clip the the shape file onto this. You see that the larger one, this bigger one, this is the data we were working with. And then I have now clipped this area, this shape file onto um, the the Landsat data. Okay, so now let's take it from here. After we did this, we also created so you can see we have Asante, Achim North, okay, okay, and then you have Agogo, all of this, and this is already on the classified data. So now there are a few issues that we need to deal with. When you right click on this classified, so now let me extend this so that you see the name. You see that this is the points. We created the points on um, the accuracy assessment points of the clipped image, right? And when you are creating the accuracy assessment, that's what we did earlier. You go to the geoprocessing and then you look for accuracy assessment, and then these points will now fill in for you. But there are some few issues that I want us to deal with. When you come to the attribute table, so you look at this, you will realize that the classified area is giving you -1, meaning it's not capturing any data. You understand? Which is not correct. We cannot use this. So what we are doing is we are now coming to export the whole thing again into Google Earth. If we don't deal with this data, we will not be able to work with it in Google Earth. Secondly, another issue is look at the ground truth. You see that it's written 4 over here, but we have vegetation as the class name. Now, the vegetation is not supposed to be 4. The value is not supposed to be 4. When you look here, you realize that when we're creating the schema, the first one was water. The value 1 was water. Value 2 was vegetation. So here it's supposed to be 2 instead of 4. Then we created a third one, which was bare land, which we later removed because we didn't need. However, that value was 3. So we do not have 3 here again. The built up area is going to be 4. So we have 1, 2, 4. But you see that the data over here, where we have water, instead of water being 1, it is showing 2. You get it? So when you know it's not correct, we don't need it. We have to correct this data. So the first way to correct this classified area is to update this layer over here. So the next step is to go here, then look for update accuracy. So you see update accuracy point, this one over here. So you choose your raster. Which one is our raster? Our raster is the classified clip. You see, mine is classified clip. That is this area. So this is the classified clip. Then we have the inputs accuracy assessment point. That is the point that we created. This one. We don't need to fill the dimension. That is used for time series analysis. So our target area is where? It's not the ground truth, it's the classified column. So we will leave this one as at what? Classified. You get it? So that it will pick the data from within the actual points that we have created, instead of it telling us that it's not capturing any data, which is the negative. So we will run it. All right. So after running it, we are going to get, so you see that we have two accuracy here. This one is the one I just closed. Then we have this one over here. Let me remove this from it and then keep this, the updated one. So this is the updated one. Now we'll be working with the updated version. So you still right click on it, go to attribute data, and when you get to the attributes, so when you get to the attribute, you realize that now the classified is now showing 4. You get it? When we open the old one, look at the old one. The old one, this is the old one. You see that it's negative. Now let's close it. You see that the new one, the classified update, is showing classified 4. You get it? So now we can work with this data. In fact, there's another issue that we have to deal with. Look at the class name. The class name over here is vegetation. You get it? It's vegetation. Now, this vegetation is not supposed to be 4. Vegetation is 2. Let's go down. This is water. Water is 2, but water is supposed to be 1. Okay. So you see that water is 2, all of these. So now let's put in a simple script for the class name so that it will give us the actual name, the actual variable. So we will right click on the class name, the top here, then we'll go to calculate field. So when we go to calculate field, we will now use the script over here. I'll put the code in the comment section. We will tell this machine that we will tell it that this column, we will tell it that anytime it sees 1, if the value is equal to 1, then he should return water. So the name or the label for value 1 should be water. Else so else if the value is 2, then return vegetation. Because we are not using 3 like I initially said, we will ignore the 3 and then move to 4. So we are saying that anytime the value is 4, return water. Apart from these 3, 1, 2, 3, any other thing, it is unknown. So that's why we have else. This one is else if, that means it's an option. So this else, we don't need this one. Sorry, any other thing that is not part of this, else, any other thing, call it unknown. So let's come to this section. This section, we will call it the class name. Let's say that get underscore class name. I will paste all of these codes. Then we will open this. And then within that bracket, what we are calling. So all of these values we are calling, those values are supposed to come from a certain table. So we are saying that the values that we'll be calling, let's call it from the classified table. So anytime you see that value here, so in this box over here, we'll just double click on classify, this one, and then it will fix it between this. Now apply. Okay. So now I believe you can see. You see that now, because of the scripts that we wrote, it is telling us that the built up area is 4. When we go down and then we see vegetation, you see that it's now 2. Look at vegetation here, it's 2. Then we'll go down again. Let's look for water because we have just 3. So let's look for, and so water is here, and you can see waterfalls in here perfectly. So now that we have been able to work on this, we should now export it. Let's export it so that we can work with it in KM. Let's export it to KM. Okay. 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 So I was looking for save. So I think it has already been saved. So now let's keep it this way. So now let's go and export it. Layer to KML. So layer to KML, just like we already did, just that we didn't have the correct point. That's why we are doing it again. So input layer should be our update. We are going to use the update because that's the correct one. And okay, we can still turn it on and then select everything over here. We should have about 300 points. Okay, so let's export this. Okay. And so these points should be in okay, so I think it's done. Let's go to our projects and open it from there. So we will find it in or we can even save it into the folder that we created. I think let's make it easier, but better still, if you come here, you should find it here. Classified to KML, this one. So we can still use this one, or you can okay, so you see that we have 2. This is the old one. Let's delete it and then let's use this one, update. Or you can choose where to save it. It's up to you, but we can still open this one from here directly, and that should be fine. So this is how you check whether what you did was correct. Into Monshadi, into Shadio. Let me see. So look here. You realize that this is the one we just created, the update accuracy. When you open this box, it opens this for you, the drop down, and all the names are here. So if you did the calculations, like you wrote those scripts and all of that, you are going to find these things here. Now look at the first one. When you click on the first one, it should take you to a built up. So is this a built up? That is the first question. This is not a built-up area. This should be vegetation. So now we are going to assess the accuracy. We are going to deal with the accuracy issues. So the same way, this is the update accuracy. So I'll right click and go to attributes. Now you see the first point over here. Look here. This is the first point. And this is also the first point, the built up. We are saying this one is not built up. So let's tell the computer that this is not a built up. This is rather vegetation. So if it is not vegetation, then what is it? It's a no, sorry, this is not a built up. It's a vegetation. If it's a vegetation, then we should change it to what? 2. Vegetation is 2, so we'll put 2 here. Then you look for the second one. This is also built up. Okay, so we are saying this is also not correct. This is also vegetation. So we will change this to 2. The same way, this is, so this is also not a built up area. This is vegetation. We will change it to 2 because 2 is vegetation. So like I was saying, so this is supposed to be built up, but it's not. So we have 1, 2, 3. So 1, 2, 3. So the fourth one is this. So that is also vegetation. This is also vegetation. This is also, it's still vegetation. Then you come here, built up. So it's also vegetation. So depending on what you see there, you change it to reflect the actual situation on ground. It's still vegetation. This is built up. No. So it's still vegetation. We'll change this. We'll change this to, let's see, this is vegetation. So this is correct. This is okay. So this is built up. I think this should be barren land. I think this should be barren. Okay, let's leave it. This is not built up. So after vegetation, this is vegetation built up. Okay, so 1, 2. So this is vegetation 2. This is, oh, sorry. This is also vegetation. That is vegetation. So 2. So it means there's been lots of misclassification here. I think it's because we only used 3 classes. So you keep doing it this way. You keep doing it. If if you check and it's not correct, so if you selected 500 samples, that's how you're supposed to do it. So where are we? We are here, vegetation, this one. Mhm. So let's see, is it vegetation? Okay, it's vegetation. Let's go to built up. It is not built up. So yeah, this one. So two. This is no. It should be this instead. That is also not a built up. So still two. Vegetation is correct here. Right, yeah, vegetation. This is built up. Is it built up? Yeah. No. So we still change to, then it's still built up. Sorry, it's still vegetation. So you keep changing. You keep changing it. This is vegetation. Yes, so it's still vegetation. It's fine. This is vegetation, so we don't change anything. Yeah. So that's the logic behind it. If it doesn't fit within that space, you change it. So let's go to built up again. I don't think it's built up. So let me mass view and then I'll mass change it. So you see all these areas that have been classified as built up are not built up. So I will view all of them and then I will change all of them. Alright, so they are all not correct. So I'll start changing from here. 2, 2, 2, 2, 2, 2, 2. And then we'll get to vegetation. See, vegetation is here, so we are here, vegetation. And that one is correct. So let's go back to built up again. Here, built up. All of these vegetation. Yeah. So let me change this also to 2. And then we get here, we are here now. So these 2 built up and built up. It's also vegetation. So these 2 will change to, and then we get here. So we are here now, and this one. Okay. So we have to change this to, as for the vegetation, I think it's right. Okay, this, so is this built up? No, this is vegetation. So it means we change this. This also should be vegetation. Yeah, so this is also vegetation, so we keep changing it till we get the right one. So afterwards, in fact, we need to work on all of these. I think this should be vegetation. This should also be vegetation. You work on all of these, and when you are done, you compute for confusion matrix. This is not a built-up. So let's look at this. This is this area. They are all not built-up areas. All of these are vegetation areas. All right. So, I mean, it's just the same process. You need to make sure they are all aligned and your ground truth is just as it is on the ground. So you can work on the rest, and then you save your edits. So now we are done with this one with Google Earth. So after all of these edits over here, the next thing that you do is um, you compute for your confusion matrix. That is how many classified inputs did you get wrong, and vice versa. So you compute for the confusion matrix. So that one, you come to GeoProcessor and you type compute confusion. So you can also go to image analyst tools and then you find it there. And so your confusion matrix will be your updates. That is this one, what we are working on. So it will compute this and this for you. And then you save it, you choose a location. I want the default one, so you just run it. And we are done. We are done with the matrix. So you come here. When you come down, you see the standalone table, confusion matrix. You can just open it by clicking on it and click on open, or you can just do control T. Then it will calculate for your kappa coefficient for you. So the kappa here is 0.6, meaning that I think the normal figure should range around 0.7. Yeah, 70%. This is 60%. So it means that there are a lot of errors. I mean, this is for tutorial purpose, so you keep it that way. You can also copy it and put it in AI for it to interpret it for you. Let's try one and see. Anyway, let's see. So we'll come back and check. So I mean, at this point, this is all that we need to do under our accuracy assessment. The next thing is for us to uh, do what we call the change detection. So we'll do the change detection by using a change detection tool up here. I will pause and then go and find, because it's change detection, we need two data from two different periods. This is from 2010 to 2012 to present. Let me download the data from 2000 to present, and then I'll do the same thing with that data. Then we'll do the detection. Then the same samples, because we are going to do the detection, the same samples that we use, we are going to use the same sample for this also. And then everything remains same. Let's classify and see whether it's going to work. Okay, fail. So the truth is, since we are having problems processing this image, because there are lots of clouds in it, which will not help our processing. So this is what we are going to do. I'm going to show you how to do the detection in a different um, layout here. Then we'll come back here and do the covariates to this particular image. So I already have an existing folder, this one. So let's do it here. But I assume that if you are doing it on your PC, you should have both ears so that you do the line detection with both ears on your computer. So so let's come here. Let's use okay, so I have done the detection here, so I'll take that one out, and then I'll take this out. I need so we need only this. This is land use LULC 2000. This is 2000. Let me also take this out, and then let's use so this is 2000 and this is 2011. So we can use one of these, and you realize that there are about 1, 2, 3, 4, 5, 6. There are 7 classes here. That's why you see all of these. So we are going to use LUSC 2011 and then 2000, between these two. So if you have your data like this, you see, first of all, you can even see the difference, because look at this. Okay, let me put this on top of this. So this is 2011. This is 2000. When I turn this off, you see that there's a change. There's a difference between these two. I can also look for I can look for the swipe, and when I swipe, you realize that some of the areas, for example, this side, this side was um, vegetation. Now the water has covered this area, which I think it's okay. It means the water is expanding. So you see, you can use this to look. Okay, so the water over here has also reduced. So you can use this tool to first have a glimpse of what, or a preview of what you are looking for, what you are expecting. So to do the detection, you come to imagery, then you click on change detection wizard. You click on this, and then it will open this for you. We want to do a categorical change. That means change between two thematic rasters. So we have this and that. So we want to choose the first one. Then we are saying that we want to see the change from, so the change will be from 2000. So from 2000, ULC 2000 to 2011. What has been the change? This, where is LULC 2011? This, and and then we can run it. So I have the classes that I have here. I have the same classes here. In fact, that's why I didn't use the first one, the one that had clouds, because we would have to create same classes for it. And then next, we can leave this at none, and then raster data. You choose a location, and then you can run, or you can do a preview. All right. So this is the output, and you can see it from this side. You see that it has changed. So when you come up, you should see this one, detection. This is what we just created. So it is telling us that this color changed from water to developed. Let's go to the attribute table. Okay, um so we are saying that this one probably is too small, that's why we are not seeing it. But we are saying that this area was water. Now it has become barren. Okay, I've seen it. It's here. This one. This piece of land. This one. This. It was water. It has become barren. There's also another one. Where is it? So you can go through all. So this one is more pronounced. We are saying this area was water. It has turned to a cultivated land. So we have one here all along this side. This one was water. It is now cultivated, which you should definitely know there's a problem. But we move. So this is what you are going to get. All the areas that have changed from one to the other, and there are areas that have also that did not change. You see all of these areas with the highlighted colors, they didn't change. You get it? So this is for the change detection. You can also use the combinatorial and then you put in some formulas, but this tool will do the work for you. You can just do combinatorial, or and then you fill in there with your data, and then it will just that when you are done, you have to program it to reflect the change that you see here. This one. So this is for change detection. Then we will next look at multivariates. We'll add our multivariates to do so that the multivariates will tell us the change that has occurred there was as a result of what. So in the multivariates, we have the slope, density. In fact, you can see all of them here. The slope, the density, and all of that. So we will add it. I'll show you so that you add it into this layer, and and then we can create some random points and run a regression analysis on it. Okay, so now we may want to um, add our covariates, find causality, and then perform regression. So the first step in performing our regression, or the step towards regression, is to first create random points. So we are going to generate random points on the detection, this change detection that we created, this one. So we are going to create random points on it. So we will go to create random points. Now your output point feature class, we will just call this points random points new, because I already have such name. Then we will come to the constraining feature class. So this is supposed to be our area, our shapefile, our district shapefile. So this is, I don't know, I have changed my locations. Anyway, let me try and see. But that should be our shapefile here. And then we can leave all of these. Okay, so the number of points, let's create about 500 points and see. If it doesn't work, we'll create less. Okay, let me start with 100. Only created my random points. As you can see, random points created. Please, if you are creating a random point, the name, you remember the first error, it says the invalid table name. This side had a space in it. You can check from the previous name. It had a space. Please don't put any space. Make sure all the names are together. You can use underscore or whatever. So after creating these points, now we have these points over here. After creating these points, the next thing that we have to do is we have to extract the values. So now we are going to extract the values on this change detection onto these points. You get it? So that the random point has the new land cover class value. You see that this is the new land cover class value, this one, the change detection, because we detected the difference, the areas that change from one to the other. This has the new values. So we have to now extract this onto the random points. So we'll look for a tool called um, extract extract multi values to points. So extract multi values to points. Then we have our input point feature. Obviously, that is our random point. And then our raster here will be the change detection. Like we said, we are putting um, the change detection into um, we are putting the change detection into we are merging it with a point. We are extracting the values onto this one. So this onto this. And then let's run and see. Okay, so that's perfect. So we've now extracted our values from here to here. Let's look at the attribute table and see. Okay, so each point now has a value over here. You see there are now figures here. We will have to clean this data. We will clean it as we go ahead. So after doing this, we need to now add our um, covariates. We need to add our covariates. And initially, okay, we will try the first method. If it doesn't work, then we'll do the other one. The method I wanted us to use is that all the variants that we want to use, we will create, we will add field here, we will add this field, and then we will create um, different fields for the variants here. However, I think we can directly extract it. So let's just add the data. You can see I have the data here already, but because I changed the location, it's not showing. So let's add maybe just two. Um, so let's add let's just look at distance from built up. Let's look at this, and then let's look at temperature. We are just trying to see whether these variables have any, and then distance from highway, they have any bearing on the change and population density. So I think this should be fine. So now our variates should be here. So you have 1, 2, 3, 4. And so and so we will now extract the covariates to the point. So since we already have it, let me just close this and then go to extracts, just like we did for the first one. Let's do extracts multi-values to points. Mhm. So you see that the points that we extracted, the first one we extracted the detection. So we already have the detection points in the random points already. You understand? Now we are going to add one, the population density, 2, 3, and 4. You get it? So we are now extracting these covariates to the random points. So we can just run it and we should have a success here. So let's go to the attribute table and so you see when I said we should um, create the table, we would have created all these tables and then place the data in them. But now you see that we already have these fields. So we ignore the first one. So now we have our chain detection. We have this, we have that, we have that. We have all of these variables here. So now that we have points that has all of these variates, the next thing we have to do is to clean the data. I think I mentioned this earlier. Let's clean the data. By cleaning it, let's go to attributes. No. Let's go to select. Select by attributes. And now we will tell this that where, so look at all these things that we have here. So we are going to clean all of them. So we are saying that where change detection is equal to now, you can just type now. Apply. Okay, so it means we don't have any here. So let's select another one. All of the we'll clean all of these variables. So let's check population density now and then apply. And we should have, okay, so 0 selected. Let's check the other one too. Distance from where it is now. Okay, so we still have 0. Wow. So average is now. I think there should be an issue because population density we have now. Let me go back. Population density is now. This is what I'm talking about. So when you do this, where population density is now, it will select, you see that it has selected about 30. So all you have to do is to come here and then delete it so that it doesn't return any now value. Let's try distance and see. We have 0. 0 built up. Okay, so let's check if it's correct. If we don't find any now again, we still have now in the change detection, but we can ignore that one because we may not be using it here. But let's try and see if we can. Okay, so we have 6. We can see 6. So let's delete it. Mhm. So at this point we are done. We are done cleaning our data. So we now have to. So now the point we created here, the point we created here. You see the points we created here have been merged with our change detection, have been merged with, so each point has one value for change, population, distance, value, temperature, and then built up. You can add all the covariates in the folder and that will be fine. I just want to focus on this one. So the next thing that we have to do now is, since we have all of these, we can now perform our regression. And I remember we used, in class, we used exploratory. So you come to geoprocessing and then look for exploratory regression. You can see exploratory here. You can also use other regression. You can do explanatory and logistic regression, depending on what you want to do. But let's use exploratory. And then so our input feature here will be the random points, and our dependent variable will now be r. So this is our independent. It is dependent on the detection. So look at this and these variables, look at this, and then tell me whether the change over here was either dependent on this, that, or that. That is the meaning of what we've done here. So the the we will select these variables 1, 2, 3, 4. Um, so these are the variables we want to explain. The weights, we can ignore all of these. Output file. Okay, let's create an output file into our projects. Yeah, and now make it out2 or output2, output2, and then output results. I already have similar here, so out output refs 2, and then I will run it. Alright, so even though it's run, there are a few warnings here. So it's using the adjusted R square and all of that. But let's look at the warning. Distance from for geographic coordinates are analyzed using quarter distances in meters. So I think there's an issue with the spatial references. And then it can also not construct models with 5 variables. because we selected one, two, three, four, five. Okay. So maximum number of variables is 4. So you can see your results here. This is 1 out of 4, the 4 that you used. So you see that it's exploring different models. So it is using the R squared model, this one. That's why we call it exploratory. Then it will also use the Pearson model. Then, sorry, out of these models over here, these ones, they are R squared. This is the model that is Pearson. And then we also have the second results here. We have the third results here. And then 4 out of 4. So population density and all of these ones, you don't have to. So criteria passed. Um, so you need not to worry about this. All you have to do now is just this, copy the information here, and then put it in Google or any AI to explain it for you. You can just so the tables are down here. If you later want to find it, you just copy from here, find any reliable AI, and then you put it in to do the analysis for you. So basically, we are done with all the 3 weeks. We've done um, um, data, Landsat data, and then we also did what did we do? We did classification. We converted to KML, and then we did accuracy assessment, and then after the accuracy assessment, we did change detection. Now um, we've done regression. We've added the covariates and we've done regression. So the data that we copied, let's see if we can just paste it somewhere. Uh, let me use, you can just paste it and then, so the next thing that we are supposed to do is spectral indices. That will be the last thing. I will upload that in the next video. Uh, let's just look at the interpretation. Mhm. So what does it mean? Our regression initial warnings, these are not errors. You're on latitude. Like I said, the spatial reference has an issue. So when you are dealing with yours, you need to look at that. Global summary of 15 tested models. So it tested 15 models, and over here, 0 passed, uh, 0 passed, none passed the model. Um, the very best model you can make with these 4 variables only reaches a maximum. So even the best model, the one that even had any number or any figure, was 9%. Yes, so we cannot see that those variables had effect on it. Now our maximum VIF, that was 100%. perfect results. All values are lower than 1.4. There is zero multi-collinear collinearity. None of your variables are correlated with each other. You do not need to remove any variable for overlap. Okay. So I mean, just put it in here. It will explain everything for you. And then population density, only significant predictor. Yes, so this could be the only significant predictor. And it has 65% models.